All right, let's dive into the digital backbone of modern construction. We're living in an age of these massive, sprawling projects. And honestly, just managing the sheer complexity of building our cities is one of the biggest challenges we face. So how on earth do they do it?
I mean, really think about that for a second. You're building a skyscraper, or a hospital, or a whole new city district. You've got countless teams, architects, engineers, contractors, you name it. How do you possibly keep everyone on the same page? Because that's the reality. You're juggling millions of files, architectural drawings, structural models, budget spreadsheets, compliance reports. It's a literal ocean of information. And if you don't manage it perfectly, you are absolutely heading for disaster.
See, without a central system, you get what we can call the construction data maze. It's where the structural team is working from, say, version 2 of a plan, but the electrical team is still on version 1. And the result? Well, it's costly rework, missed deadlines, and a whole lot of frustration.
But what if there was a way out of that maze? What if there was one central, trusted place for every single piece of project information? Well, there is, and it's called the Common Data Environment, or CDE for short.
So, here's the crucial point. A CDE acts as the project's single source of truth. Think of it like the central nervous system, making sure every single person is looking at the most up-to-date information all the time. But how does it actually work?
Okay, so a CDE isn't just one piece of software you go out and buy. It's really an ecosystem of technologies all working together. We can basically break these down into two main categories that are absolutely essential for making the whole thing happen.
Think of it this way. On one hand, you need the actual platforms for people to work together. Those are the collaboration tools. But on the other hand, you need a shared language so their software can work together. And those are the interoperability formats. You really can't have one without the other. They're both totally critical.
Now, what's really interesting here are the trade-offs. Cloud platforms give you this amazing real-time access, which is fantastic, but they obviously rely on a solid internet connection and can get pricey. Then you have BIM, Building Information Modeling, which is basically a super detailed 3D digital twin of the project. It's incredible for spotting when a pipe is going to run right through a steel beam before it gets built, but it requires serious skill and creates these gigantic files. And the same thing goes for the data formats. You've got open formats like IFC, which are designed to be a universal language. The whole point is to stop you from getting locked into one company's software. But then you have proprietary formats, like a Revit or a DWG file. They often contain way more precise design data, but they just don't play well with others. This tension right here is key.
And that brings us to the twist in our story. Just because you have all these powerful tools, it doesn't mean your problems are magically solved. There's a hidden challenge here, something we can call the universal translator problem. You see, the biggest hurdle is getting to what we call true interoperability. And what that really means is getting all these different systems made by all these different companies to talk to each other perfectly, without dropping a single piece of critical information along the way. And this slide just illustrates that core conflict brilliantly. Open formats are chasing this dream of a universal language that everyone can speak. But proprietary formats, they're built for perfect, flawless performance, but only inside their own walled garden. Trying to get them to talk is like translating a beautiful poem. You just know you're going to lose something in the process.
And here's the proof, right from the source material. When you move a complex 3D model from one program to another using one of these so-called universal formats, some data can be lost during export/import. And you know what? That tiny bit of lost data could be the difference between a pipe fitting perfectly or causing a major, expensive clash on site.
So, if technology alone isn't the magic bullet, then what is? Well, the real solution lies in looking beyond the software and focusing on how people and processes fit into the whole equation.
A truly successful CDE really rests on these three pillars. First, a balanced tech stack that uses the right tool for the right job. Second, clear protocols, like the international standard ISO 19650, that basically set the rules of the road for everyone. And third, and this might be the most important part, consistent workflows, so that every single person on the team is trained to put data in the exact same structured way.
And that's really the ultimate takeaway from all this. You can have the best, most expensive software in the world, but if you don't have agreed-upon rules and well-trained people using it, you're still going to have chaos. Success here is fundamentally a human and organizational challenge. So the blueprint exists. The technology, the standards, the strategies for a truly collaborative future, it's all laid out for us.
The final question isn't a technical one at all. It's a human one. Are we ready to change how we work and build not just our structures, but our collaborative processes too?